Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to discuss on chapter 4, source transformation. So what is source transformation? Basically, the idea of source transformation is to transform a voltage source. A voltage source must be in series with a resistor. So you have a VS here, voltage source, and you have a resistor. What to transform? You're going to transform this series configuration here into a current source in parallel with a resistor. So basically you're going to have the same resistor, but now you're going to transform the voltage source here to current source. But how to know the current direction? It is by looking at the positive side of your voltage source here. So because of the positive is up, then you're going to have an arrow going up. So this is basically what is source transformation. And if you have a current source in parallel with resistor, must be in parallel, and you can transform it to voltage source in series with resistor. So vice versa. If you have this in parallel, then you can transform to voltage source in series, or vice versa. Voltage source in series, you can transform to parallel form. Okay. So next, over here, you can recap. If you have a voltage source in series, which is the picture number 1 here, if you have a voltage source in series, you can add all together. So how to add this? This is by looking at the if this is a current direction going to the left, and you will see positive side first, positive 2, and then minus 12, and then plus 5, and then minus 8. What you will have is, you do the math, so this is plus 2, minus 12, plus 5, minus 8, and then you will get minus 13. But for resistor, yes, if resistor in series, you can add together. So this is a voltage source, this is a resistor, summation of all. So resistor is 8 plus 1 plus 4, which is 13 ohms. This is B. But how to how to draw this? So since you start from left side at this, maybe I put it A and B here. So you can draw A here and B here. Since you start from here, then and this is negative 13 volt. So you can have this and minus first, because this is a minus sign here. So you just put negative and a positive here, and then the resistor that you have. So this is 13 ohms and 13 volt. Okay, no need to put the negative because you already have the negative sign there. Okay, so this is for series circuit. And then number 2, figure number 2 here, you have all current source in parallel, so you can add all together. Okay, but what is the direction of your current? Okay, if you say that going up is positive, then you can have a plus 9, and then since this is going down, so you have minus 2, and then going up plus 5, then this is 12 ampere. And since this is positive, then you have going up here, and this is 12 amps. And then and the resistor, this is current source, summation of all current source, and you have a resistor, which is 8 in parallel with 12. So you can use your calculator. You will get 4.8 ohms. So since they are in parallel, so you can draw resistor in parallel. And this is A and this is B. Okay, so resistor here is equal to 4.8 ohms. So this is how you do the parallel and series form. Okay. Alright, now this is source transformation. The idea is to transform whether this is independent source or dependent source. If the voltage is in series with resistor, you can transform it into parallel form of current source with this resistor. And if you have a dependent source in series with resistor like this, and you can transform it into current source in parallel with resistor like this, vice versa. So current source into here, or voltage source into this, so vice versa. Okay, let's go to the practice. And before that, if you have a current source in parallel, because I forgot to mention about this, and you know that this is a IS and this is a resistor. You're going to transform into a voltage source in series, right? So this is a R. So how to calculate the value of the voltage source here? This is just apply the Ohm's law. V is equal to IR. So what is your I? I is the value of IS here. So IS and then into R. R is this value. So the voltage will take the value from I and R here. So you will have this. And same as if you have a voltage source and you're going to transform into current source here, these two here, then what is IS? IS is equal to V over R. Where is this V equal to? V coming from here. Okay, so V divided by R here. Okay, so this is how you calculate your value of transformation. Okay, let's erase this one first. So the steps to do the source transformation is, if you have, let's say, this unknown I naught, this is the value of interest you're going to find in the question. Usually question will ask you find I naught using source transformation. So your task is not to transform this pipe. Okay, please do not transform any unknown. Okay, so for the first step is do not touch this unknown, or do not transform this unknown or the value of interest. Okay, the one you're going to find, because if you transform this, you're going to remove this I naught. Okay, so please do not touch it. Number two, you're going to find any resistor in series, you can add. And if you find R in parallel, you can use the parallel rules. This R1 parallel with R2. Okay, and then if you find anything like a voltage source in series, you can add. And if you find that you have IS in parallel, current source in parallel, then you can also add. But you need to observe the rules, going up positive or going down negative. And series, yeah, depends on the last slide we had. And then number 5 is to transform. Use the source transformation. Use the source transformation to transform the voltage source in series with resistor into the current source in parallel with a resistor. Okay, and vice versa. Okay. Alright, for your example here, since 6 and 3 they are in parallel, then you can do the 6 and 3 parallel, then you will have 2 here, and you have 5 going up, just draw as it is, and then you have a negative plus here. This is 5 volt, and then you have 7 ohms, but because 7 ohms have this I note, the value of interest, you will not touch this. And then you will have the 3 amps here, and then the resistor here, they are in series, then you can combine, which is add them. So 1 plus 4 is equal to 5 ohms here. Okay, and then fine, if you have any other current source in parallel, are these two in parallel? No, right? So if they are not, why not? Because they have something else. And you know that a parallel is when you have end-to-end mix, right? Like this. End-to-end mix. So you can use the parallel rules. But since you have 5 volt here, they are not in parallel. So what should you do is you cannot combine. Yes, you cannot combine. So you can do the source transformation because you don't have any other means. So since arrow is going up, then you will have a positive side up and then negative down, and then you have a resistor, which is this resistor 2 ohms. Make sure, because they are in voltage source are in parallel with resistor 2 ohms. The current source is this current source here is in parallel with this, so you can transform a voltage source in series with these 2 ohms. So what is the value for your voltage? So V is equal to IR. So here I is 5 amps into 2, then you will have a 10 volt here. Okay. A 10 volt here, a 10 volt and 5 volt, you can add them because they are in series. You will have a 15 there, and then yeah, do the combination like this, and then you will get our step here. So this one you're going to transform because they are in the voltage source is in series with 2. This part, they are in series. Then you can combine it, and then you will get these two. If you transform 15 divided by 2, you get 7.5 for the current source, and they are in series. So you will have this. Since all here they are in parallel, if you look at here, they are in parallel. The 7.5 with the 3 amps here, you can add them together because they are current, right? So over here you will have a current source going up with 10.5 amps because they are, yeah, you add them up, and these 2 and 5 you can combine. Then what do you get here? 1.429 ohms. You will have your last part. This is 7. This is I note. So use your current divider. I note is equal to 10.5 into 1.429 divided by 1.429 plus 7. So what do you get here? Okay, and yes, you will have 1.78 ampere. Okay, so this is the last answer. So the final answer will be 1.78 ampere because this is the last thing you're going to transform. Okay, with that, I think that's all. Thank you.